everyone, welcome to my YouTube channel Learn SQL with Shahid. In last class we were discussing about uniform extent, mixed extent, and also GAM, SGAM pages and IAM page. Okay, so like what is mixed extent? Okay, mixed extent means we have in an extent 8 pages, right? Different objects are occupying spaces on pages, like table 1 is occupying on page 1, table 2 occupying on page 2, table 3 is occupying on page 3, table 4 is occupying on page 4, like that it goes on. So different objects, like table is known as an object, index also is known as object. So different objects are owning the spaces, okay, on the pages. So it is known as mixed extent. Uniform extent means single object is owning all extent, okay, all the pages in an extent. So it is known as uniform extent. Means I also have explained it, like here for example we have this extent, we have collection of 8 pages is an extent, right? Here say in 1 MB capacity, if we see here this much, okay, here if we see this till here, it is 16 extent, 1 2 3 4 5 6 7 8, okay, into 2 means 16 extents. 1 MB data occupies 16 extent. Another here also it is 16 extent. It is 1 MB plus 1 MB is equal to 2 MB. So in 2 MB we have 32 extents, okay. So like mixed extent means table 1 is occupying on page 1, table 2 is occupying on page 2, table 3 is occupying on page 3, table 4 is occupying on page 4. Again table 1 comes and occupies on page 5, data page 5. Table 6 will come and occupies on data page 6. Table 1 comes and occupied on page 7. Table 1 comes and occupies on page 8. This is known as mixed extent, okay. And also it is proven here. If we see in another example, T1 page 1, okay, table 1 again on page 2, table 1 again on page 3, like for everything here it is occupying, okay. This all extent is occupied by T1 only, okay. So then this extent is known as uniform extent, okay, because single object is owning all the extents of the pages, okay. So it is known as uniform extent. Hope this might have understood. Also I was explaining this GAM and SGAM, okay. If the bit is 1, then the extent is free in GAM. If the bit is 0, then the extent is allocated in GAM, okay. Also we have GAM and SGAM, this strong combination. So what this means is like I have explained in previous example what is SGAM. So this definition you can't understood. So simple definition is GAM tells the story about the how much the extent which is free, which is allocated. You can say that in interview. And SGAM means it will tell the story about the extent which is mixed, which is uniform. That is the definition. So like I will be showing you the combination. Here free not being used means if you go here, this is not being used, it is free, okay. If it is not allocated means in GAM it is 1. Not being used in SGAM means 0, then this is 1 0 combination here. Here 1, this one is 0. Okay, and 1 0 combination is for T1 table. See here, from next onwards you can consider this one, down one T1 again. This T1 is a prune table, so it is again going next extent like this T1. This is for prune table 1 0 combination. Or else you can say like if the in GAM if it is free, that is 1, and SGAM means here, see here, SGAM means not being used, then it is 0. Uniform extent means means in 0, 0 combination, uniform extent or fully mixed extent. This is actually occupied, everything here also occupied. This is uniform extent, this is mixed extent. So then it is 0, 0 combination here. And again, if you go to Word document here, mixed extent with free pages means here whatever it might be, like in an extent. See here, you consider this another example. If it is mixed, okay, T1, T2, this is mixed. Okay, some pages are left free. Then we have 0. Here it is allocated, right? If it is allocated, then 0 in GAM. If anything left free here, then it is 1. Then 0, 1 combination. So like this it works, okay? GAM and SGAM. So hope this might brought you like strong understanding. And also like I was explaining this index allocation map, a map that extent used by index or table. Every data page, you know, like here, if you go to that picture again, here data page, right? Page, data page. Every in an extent, every page has no like it has one IAM page. Every page contains one IAM page, okay? And also this indexes as well. So it tells the story about 4 GB chunks. Like we have PFS page free space page, right? In our last discussion. So it tells the story about the pages, okay? 8088 pages. Same like that. Every page has IAM page, okay, in it. So it tells the story about 4 GB chunks of the table pages or index, and also it is called as that 4 GB chunks is called as IAM interval, okay? So that is the thing I have all explained in my previous classes. So like also I have explained this DCM. DCM is Differential Changed Map. Track that have changed since the last full backup. Last since full backup means Sunday to Sunday, one full backup will be there. Whatever the Monday data changes happen, say insert, update, delete, that DCM pages tracks, okay? If without DCM pages, there is no differential backup. And also it has allocation like 1 bit 0 and 1. If the page says if it is 1, then it got modified. If it is 0, then it is not modified. Same structure it follows for this also, ones and zeros it follows. Like now we will be discussing about BCM, okay? That is bulk changed map. Whenever this tracks the extent were modified by bulk operations in the last full backup. Like in SQL Server we have DML operations, right? Like data manipulation language, that is insert, update, delete, okay? Same thing in bulk changed, we have bulk insert, like someone has to insert 1 crore records in one shot. So when doing this, like we can take the data from Excel sheet which has 1 crore records, and we can store it in a database. Okay, I will show you this in practical as well. So how to do bulk transaction? At that time we will do bulk transaction whatever the pages is modified, right, during bulk operation. So it tracks by BCM pages. Okay, bulk changed map, that is known as BCM page. Okay, that's it, nothing else like important in this. Like whatever the inserts, bulk inserts are there, that is tracked by BCM pages. That is the thing you have to know. Like that's it in this. We have finished all eight types of pages. Also, one thing I have to explain you guys, like in a database, in each and every file will be having this order in a pages. Okay, page 0 is file header. Okay, it contains attributes of the file. Okay, whatever the page, that is known as page 0. Page 1 has PFS, page free space. Okay, page 2 has a GAM, page 3 has SGAM, and page 4 is unused, and page 5 also unused, page 6 is DCM, and page 7 is BCM, page 8 is unused. Okay, I have discussed these things and all till here, BCM pages. So from page 9 it is boot page. Okay, and also page 10 means this also I have discussed, index page and data page. This is actual data which is stored in the database. Okay, so boot page is ninth page. What is boot page? I will be explaining. This thing you can answer in like higher interviews like Microsoft, like that. You will be not having in normal interviews. You will be facing this in Microsoft interviews only. So we have boot page, right? That you can say it as example. It is the special data page, and only once per database. Okay, one exists only once per database. When a database is created, this boot page will be created automatically. This all everything it creates automatically. PFS, GAM, SGAM, data page. If you give 1 GB space, 1 MB space, 1 TB space, whatever we give, these pages will be automatically created. Whenever we create database internally, these things all are created. Okay, and it is the database boot page is always stored in page 9 of file 1. File 1 means MDF. Okay, in MDF file only. NDF we have MDF. Okay, so it will, file 1 means MDF. It has it is stored in MDF file. Okay, that is primary file group. Okay, same thing I have explained. Primary file group. Okay, whenever we create the database now, at that time file group also just created. It is logical, and it is created in a file 1 MDF file in a primary file group. So also the boot page contains internal database version, means we have like instance version we have now, as I showed here. If you go to instance here 16.1000.6, like that same thing in database. Here go to database, here the DB file, same thing in the database. It has database version. Okay, that is internal database version. The compatibility level also it contains. Okay, what is compatibility level, I will be letting you know, like what this things I will be discussing in future. And also we have the database name and the date, also the last log backup when it took. Okay, that date and time it will give the information. And also we have lots of other information as well. And also we have DBCC, when the last DBCC check DB was ran, that information also we will be having. everything it is in return to the boot page. Okay, these things and all we will be facing in Microsoft interview. So again, that's it. We have completed all types of pages. So let us go through overview once again. Here we have completed these topics, like we have 8 types of pages. We have a data page, index page, text image, that is large object data. So database contains actual data. Okay, whatever the actual data it is there, it will store. Okay, so like I have said now, actual data, actual data means that in a row will 31 rows, 258 characters will be fit in one row. So like when 1 MB 128 pages will be there. All that data in a page, whatever the data is coming row inserting, it will go to that pages. Okay, so actual data we are writing, inserting student column, student number, whatever the ID is there, whatever inserting, that is the actual data. Okay, we will play with the actual data only in real-time environment. Also we have a index page, contain data related to index, what is clustered index, non-clustered index, what is heap and all I will be letting you. So just know about what is it contains the information about the indexes. Also, as I showed, like varchar of max, right, in text image, large object data, whatever the images, text, videos are there, if you won't fit into in that 8060 bytes, so it exceeds that, then it goes to LOB. That means whatever the varchar of max, also images, long text, which can go up to 2 GB varchar of max. So that can be stored in LOB. So these three are the actual data, and whatever the below are metadata, PFS. It contains, also I have discussed and told lot of time that it contains information about each page in the database. Okay. So whether also it tells the information whether it is allocated or it is free, and also it tells the information about 8088 pages. Okay, 8088 pages. Again after this interval completes, again 8088 pages. And also this PFS tells about information about the pages. This below is there, no, GAM, IAM, GAM, SGAM, IAM, BCM, DCM tells the information about the extent. This tells PFS tells the information about the page, but this phi also is metadata only, but this thing only tells about the, it is not extent, it is only, it has only page information. This has extent information, everything. Also, as I discussed GAM, SGAM, you can tell that GAM means in an extent, if the bit is 1, then it is free. If the bit is 0, then it is allocated. That also not required. GAM, SGAM means like GAM. I will tell about GAM. GAM means like it tells the information about whether the page is allocated, if the extent is allocated, or if it is free. It will tell the information about that. And SGAM means it will tell the information about the extent, whether it is uniform or mixed extent. It will tell the information about that. Okay, so also this has like SGAM and SGAM has 64,000 extent information. Also we have 4 GB interval, means we can say as GAM or SGAM interval also. So this is also clear, I hope think so. And also this IAM, index allocation, tells about the story of tables. Okay, tables present in the pages, and also the indexes, and every page has one IAM page. Every page, each page has one IAM page. So hope this also might have cleared. And BCM, DCM. BCM means whatever the bulk change map, whenever we do bulk operation, at that time bulk inserts are happening, like 1 crore records we are inserting, then this BCM will tracks that. Okay, without BCM we can't track the bulk insert. And coming to DCM, since last backup, like last full backup, Sunday to Sunday, whatever the Monday changes having, or Tuesday also, backup DCM differential backups are cumulative, like whatever the Monday inform we take the differential backup. No, Tuesday also will be containing that. No need to take again the no need to restore Monday's differential backup. We can restore Tuesday's differential backup. That and all comes in backup and restore topic. So we have to wait for that. And whatever the data changes happening in that Monday or Tuesday, okay, whatever the changes we have, that is tracked by DCM pages. So that's it for today's class. I will be discussing this log architecture in my next class. So log architecture means we have this is the transaction log file architecture. So I have discussed in details about data file, MDF file architecture. Now we'll be proceeding with log architecture. We have VLF in log files, and also we have log block size, log record. What is this and all? I'll be discussing this in details in next video. So that's it for today's class. Yeah, if you like this video, please share, subscribe to my channel and support me, guys. Thank you. Bye. Take care.